students, in the previous session we have discussed about one-dimensional array, and in this session I am going to explain what is exactly two-dimensional array. Now see, one-dimensional array means what? It is a group of, or it is a collection of similar kind of data elements. Suppose you want to group together same type of data elements, means data elements having same data type, homogeneous data elements, then we can use this concept of array. For example, let you want to store integers, 5 integers, then you can declare integer array of size 5. If you want to store let temperatures of 5 different cities, then again you can declare array of float data type having size 5 for that. Means all the temperatures are of type float, same kind of data is this, and that's why we can use their concept of array. Means there is no need to declare individual variables for storing temperature of different cities. Instead of that we can declare one dimensional array. Now here see, I want to store marks of 30 students of any test, any particular subject. Then how we can do that? Instead of declaring different 30 variables, we can declare only single array of size 30. Consider all marks are of type whole numbers. Then how to do that? We can declare array like this, int a of 30. Or this is for marks, that's why I am giving name m here, m of 30. Okay, here this is what, this is a m is a array having size 30 and all the elements from that array are of type integer. Now internally again considering 2 bytes for individual integer, 60 bytes will get allocated and contiguous memory allocation is there. These all points we have already discussed. Now see, I want to store marks of 5 different subjects of 30 students. Then what should be done here? See, 5 different subjects of 30 students. For one student there are 5 different subjects. For second student again there are 5 different subjects. For third student again there are 5 different subjects. In that way, then there are 2 possibilities. If you want to store subject wise, if you want to store like first subject 30 students, second subject 30 students, means 5 different one dimensional arrays you have to declare here in this way. Like let m1 is having storing marks of first subject of 30 students, then m2 will store marks of second subject of 30 students. In this way we have to declare 5 different arrays. See, we have created here 5 different arrays for storing marks of individual subject. This first array will store marks of first subject, second array will store marks of second subject, third array will store marks of third subject. Means here we are grouping together 30 elements using one dimensional arrays. Now see, here we know that array is what? Array is a collection of similar kind of data elements. Means instead of writing all these, means instead of declaring these 5 different variables, again we can create one array. Okay, now how to do that? See, here this is a array of 5 elements we have to create here, and for that we will write in square bracket 5, because I want to create array of 5 elements, and each individual element will have internally 30 elements in it. That's why here second dimension I will write here 30, and here data type of that individual array is integer. This one is integer array of size 30, and we are creating 5 arrays here. 5 elements are there in it, and data we can give here name like marks. Getting it? Now here internally how it will create space or how it will allocate space, whatever, those details we will discuss later. But see here, what is the meaning of this thing? Whatever we have written here, that is marks is an array of type integer array every individual element of that array is of again one dimensional array of size 30, and there are 5 elements of this array. Means this is a array of 5 elements, and each array is having internally 30 elements in it. This is the meaning of these statements. Now see how individual elements of this array. The first element, like marks of the first element will be like this 0. This represent first array. Second is marks of 1, then marks of 2, marks of 3, and marks of 4. Okay, this represent one element of this array. This is the second element, third element, fourth element, and fifth element. Now this first element will have internally, this is nothing but name of that first array. Getting? Now first array will hold in it 30 elements. Then second element will again have 30 elements in it. Third array will have again 30 elements in it. Fourth one again same thing, 30 elements in it, and fifth one again will have 30 elements in it. Getting? In this way we can group together multiple array, just like we are creating one dimensional array of type integer. We can group together multiple integers and form one array. In the same way we can group together multiple arrays and form any array. This is the concept here, and this is called as two-dimensional array, because see here there are 2 dimensions. This is called as two-dimensional array. Now two-dimensional array is a array of arrays. In this way, two-dimensional array is nothing but array of arrays. This is the concept only. Getting? Now here what is the syntax to declare array, how internal memory representation of that two-dimensional array, everything I am going to discuss. But see here I want to explain that just like one dimensional array, we group together multiple elements of our built-in data types. Like multiple elements of integers, we can group together to form one array of type integer. In the same way we can group together multiple one-dimensional arrays of same data type, same size. Okay, each individual array should have 30 elements in it, and all elements are of type integer again. Then only it is possible. Then here see all elements are of size having 30 and all arrays are of type integer. Then only we can group together. Because array is nothing but it is a collection of homogeneous data elements. Elements having same data type. Getting? And this concept is called as a two-dimensional array. Now in detail we will see what is the syntax, how to declare two-dimensional array, how to access individual element of that array, what is the internal memory representation, everything now I am going to explain. Now see what we have seen, two-dimensional array is nothing but a group of multiple one-dimensional arrays. We are grouping together multiple one-dimensional arrays and all arrays having same size, same data type. Then that will be the two-dimensional array. Now how to declare a two-dimensional array? The syntax is like this. Here first we have to write data type. Then just like one-dimensional array, in one-dimensional array also we write data type, then name of array, and then in size. Okay, size is nothing but the number of elements in that particular row, particular array. Here there are multiple rows because each individual row will represent one dimensional array, and we are grouping together multiple one-dimensional arrays in that way. Okay, now see here what is the syntax. First we have to write data type, then array name. Any array name you can give here by following identify rules again. Now here a first square bracket, here there are two dimensions, that's why it is called as two-dimensional array. First dimension will indicate row size. Okay, row size means number of one-dimensional arrays. Actually row size is nothing but number of one-dimensional arrays. This will indicate number of one dimensional arrays. And second, you have to specify column size and give semicolon. This column size will indicate how many elements are there in each individual array. Okay, elements, or you can say columns in each individual 1D array. This is nothing but two-dimensional array. The syntax is like this: data type, array name, row size and column size. Here you can also specify storage class. Okay. Now see, one example I am giving here. Suppose I want to store marks of 10 different students of 5 subjects. Means one student will have 5 subject marks. Second student will have again 5 subject marks. In that way, then how to declare array? All marks are of type integer. That's why first we will write here integer marks of how many students are there? 10 students are there, and each student is having 5 subject marks. First array will have size 5, second array will have size 5, third array will have size 5. First array will indicate marks of first student, second array will indicate marks of second student, and so on up to last, that is 10th array will indicate marks of 10th student. And we are grouping all these 10 arrays. That's why the first is nothing but number of one dimensional array, that is row size is here 10, and each individual array is having internally 5 elements in it. That's why column size will be 5 here. Now see how internal structure will be. Now here first array will have 5 elements in it. 1, 2, 3, 4, 5. Getting? Second array will have again 5 elements in it. In this way there are 10 arrays. Now this first array, for accessing first array we can use marks of 0. But marks of 0 will represent whole array. Marks of 0 is name of that first array that will represent whole array, and it will hold address of that first one dimensional array. Getting? Now how to access this individual element? For that we have to use again two index. First row index, then column index. See here, first element we can access like marks of 0, and from that 0th array, this one is 0th array because array index always starts with 0 and ends with size -1. That's why the last array will be like this, marks of 9. Now see, this marks of 0, the first element, again this is again array, and here indices are again from 0 to size -1, that is from 0 to 4. That second index we have to write here like 0, 0 will be the index for first array, that is row index and column index. For second element the index will be 0, 1, then 0, 2, 0, 3, 0, 4 in this way. Getting? This one is first one is row index, second one is column index. In this way we can access individual elements of that two-dimensional array. Here the first element will be like this, marks of 9, 0, because this is 9th array. That's why here 9 will be the first dimension of this element, and second dimension will be from that array. This one is 0th element. That's why second index will be 0. Here 9, 1. Then this one is 9, 2. This one is 9, 3. In this way 9, 4. Getting? In this way the indices are. Means this element you can access with the help of marks of 9, 0, marks of 9, 1, marks of 9, 2, marks of 9, 3, marks of 9, 4. But see, here I am just representing this as a outer structure. Means internally these arrays are not stored like one, then below that second one, below that third one, not like that. Internally all the arrays again stored in continuous manner, contiguous memory allocation will be there. Means internally first array will be stored here, then after that second array, connected with that. Okay, means here let address is 100, then here 102, considering one element is taking 2 bytes. That's why here 102, 104, 106, 108, and this array is having address 110 initial address, and this one is a marks of 1 0. This one is the first element. Getting in this way, then marks of 1 1, 1 2, 1 3, 1 4. Getting in this way, all arrays will get stored internally one after other, because again it is array. Array means what? Here internally it is array, but the whole is again array of arrays. That's why again all individual elements of that array will get stored contiguously in a memory. Getting? Now if this type of array we have declared total 50 elements it will store. 10 into 5, that is number of rows multiplied by number of columns, that is nothing but number of elements in that 2-dimensional array. And you want to find out how much memory gets allocated for that. That means here size of integer into number of rows into number of columns, like row size into column size into size of individual element, that is size of int. In this way you can calculate how much space will get allocated for that 2-dimensional array. Here I am considering one integer is taking 2 bytes, then 10 into 5, that is 50 into 2, 100 bytes will get allocated for that whole array, and all elements of that array will get stored contiguously. That is again same thing just like 1-dimensional array. 2-dimensional array is an array of arrays in this way. Now using this concept I am going to explain here one program. Now see here the question is like this: we have to accept 3 subject marks of 5 different students, and we have to display it. Just this is the question only, then how to solve it. Here we can use 3 into 5, that is 15 individual variables we can create. This is the first way. Then we can create different 1-dimensional arrays, means 5 1-dimensional arrays, because 1-dimensional array will represent 1 student. Then 5 different arrays, 5 different 1-dimensional arrays having size 3 we have to declare. This is the second way. And third way, we can declare here one 2-dimensional array having dimension 5 by 3. 5 by 3 why? Because 5 different students and each individual array will represent marks of one student. That's why 5 students, that's why first row size will be 5 and individual array will have size 3. Getting? In this way, means how internally how to store, how we want to store like this. First array will represent marks of first student, like let it is S1. Then S2, here we have to store marks of second student. In this way, 5 student marks we can store internally. Now we will group together these all 1-dimensional arrays and use here 2-dimensional array concept. Now first we have to include that header file like stdio.h, that is as usual. Okay, now see next we have to write void main. In that we will declare one array. Here integer array we have to declare, and here the array name let s, and first how many students are there? 5 students are there, and each students 3 subject marks we are going to store. That's why 5 by 3. Row size will be 5 and column size will be 3. If you want to store marks subject wise, marks means first subject marks of 5 different students, second subject marks of 5 different students, then the array will be like this 3 by 5, because there will be 3 rows and each row will have 5 different elements in it. Each element of that one array will represent marks in one subject. In that way you want to store, then declare array of size 3 by 5. But here I am going to store like this: one element of that 2-dimensional array will represent marks of one student. That's why we have to declare array like this 5 by 3. Again see, in 1-dimensional array we have used one for loop to access individual element of that array. Why? Because see here this s of 0 will be this, S of 1 will be this second array, like this S of 4 will be the last array, and here individual array we can access like S of 0 0 in this way. Here this one is 0 1 0 2, here 1 0 1 1 1 2 in this way. Then here this one is S of 4 0, then here 4 1 4 2. In this way we have to access individual elements of that array. Now for that we will take to access means to access first array we will use I counter. I counter will indicate row and J counter will indicate column. In that way we will use two counters and two for loops, nested for loop we will use here to access individual elements of that array and display again. Okay, for processing always keep in mind that for processing of one dimensional array normally we have to use one for loop. For processing of two dimensional array we have to use nested for loop actually. Now for that we will declare again two counter variables, first is I, second is J. Now see, we will give message like enter the marks of first student, then second student, then third student, in that way. And for that we will first place loop like for I equals to 0, because here this I, this will indicate this one 0 1 2 up to 4. Okay, like that. I equals to 0, I less than 5 I am giving. I less than 5 you can give, or I less than equal to 4 you can give. Here 5 means see, this is nothing but here row size. Always the outer loop is having outer loop should get executed that whatever specified here as a row size, those number of times the outer loop should get executed. Okay, like I equals to 0, I less than 5, I plus plus. And inner loop we have to place for individual elements, for accessing individual elements of that array. Okay, and that is actually number of whatever column size we have specified, those number of times inner loop should get executed for every iteration of outer loop. And for that we will place here like for J equals to 0, J less than 3, J plus plus, here because column size and row size is fixed. Okay, now here how to access individual element. Now see, in this way we can access. First I will give here message like printf enter marks of 3 subjects of student. Here I want to display like enter marks of 3 subjects of student 1, then user will enter marks of 3 subjects. Again same message should get displayed like enter marks of 3 subjects of student 2, then student 3. Okay, we have to display here student 1 2 3, but indices like index is 0 based, that's why we have to place there I plus 1. Okay, otherwise it will display student 0, student 1 and student 2. Instead of that I can write here like this enter marks of 3 subjects of student 1, and for that we will write here I plus 1, because I is 0 initially, then 1, then 2, but we want to display one best message like student 1 2 3 in that way. Now see, for J equals to 0, J less than 3, J plus plus. Now what should be done here? See, we have to accept this element. Accept this element means 0 0. Here see, at this place I is 0. Whenever control will come here, first it will display message like enter marks of 3 subjects of student. I plus 1 means 0 plus 1 means 1. Then user will enter 3 subject marks of that first student, but 3 subject marks should get stored at these places. Now here index is 0 0 0 1 0 2, means 0 is fixed here, that row or whatever value of I is fixed here. Now J will get changed. J will move from 0 1 2, that is column index, will move from 0 1 2. Same thing we have done here, 0 1 2. This loop will get executed 3 number of times, and the value of J will be 0 1 and 2, that we can use to access this individual element. This first index is I, second index will be J, because see here I is fixed but J will get changed, and that point we will use here. Like here we can write scanf %d ampersand. Now the element, the name of array is S, first index is I, it is fixed here for this iteration, I is 0. For second iteration I will become 1, for third iteration I will become 2, and so on. And they will change from 0 to 2, 0 to 2, 0 to 2 every time. Okay, because this loop will get executed fully for every iteration of outer loop that we have seen while studying that nested for. Same thing we will apply here. Now s of I, and then here we have to put j. In this way we can access marks of 3 different subjects of 5 students, and same thing we have to display now. First we will display message like printf 5 student marks. Okay, now here one by one we will display all those marks. Here I am placing, see here, for I equals to 0, I less than 5, I plus plus, then for j equals to 0, j less than 3, j plus plus. Here we have to outer loop will represent number of rows, inner loop will represent number of columns. Always remember. Okay. Now here first we can write here student 1, student 2, student 3, student 4, student 5. In that way we can display. Like here we will write like printf /n student %d, comma, again I plus 1. Okay, and for that student we have to display 3 subject marks. Okay, like printf again %d, give some space here because all the marks will get displayed onto the same line. I am not putting here /n, that's why %d, then give some space, or you can also put /t, and then comma. Here what is the array element? This one we can access with 0, 0 means that is nothing but ij, s of I j. In this way, that's it. In this way we can accept 5 student marks in 3 different subjects and we can display. Okay, now here close the main. In this way we can use this 2-dimensional array concept while doing this type of questions, these type of programs. Normally this 2-dimensional array is used for matrix manipulation. Like matrix is what? Matrix is having rows and columns in it, and to handle matrix we can use this 2-dimensional array, means to accept matrix, display matrix, doing addition of 2 matrices, transpose of a matrix, matrix multiplication, every matrix manipulation programs we can do with the help of this 2-dimensional array concept. Now from that I will explain some programs. See, first I am going to explain how to accept matrix and display matrix. Okay. Now see, on the basis of that 2-dimensional array concept, I am going to explain program to accept 3 by 3 matrix and display it. Here you can accept any dimension matrix actually, like you can declare 2 variables for getting row dimension and column dimension. You can accept from user also. But here I am going to explain program that I am considering here row dimension is 3 and column dimension is 3. That is fixed. Okay. Now see how to accept a matrix and display matrix. See here first void main. Here we have to declare a 2-dimensional array for this. Okay. 2-dimensional array is nothing but array of arrays. That is one matrix is having number of rows and each row is having some elements in it. All those number of rows, these are not this, that is nothing but row dimension, and number of columns, that is nothing but column dimension, that we have to use here while creating 2-dimensional array. Now see, all the elements of that matrix are of type integer. That's why I am giving here data type as a integer. Let matrix name is m, and here 3 by 3, that is fixed. That's why I am giving here 3 by 3. If it is not fixed, then just specify here some higher dimension, like it may be maximum 5 by 5. Okay, and whatever dimension, like that is number of rows, R and C you can accept from user, that also you can do. Like here 3 by 3 matrix I am going to accept, that's why the dimension will be 3 by 3, and I is a row, I and J, these 2 counters we will need for moving from rows and columns. Okay. Now next thing, see, the 3 by 3 matrix is like this. It may be like 5, 6, 7, 1, 2, 1, 9, 3, 2. In this way the matrix may be. Okay, this is having 3 rows and 3 columns. That's why it is called as a 3 by 3 matrix. Mathematically it will be represented as in this way. Now we have to accept this matrix and we have to display the same matrix here, and for that how to write program, that I am going to explain here. And for that we have declared here one 3 by 3 matrix, I, index and j. Those variables we have declared for loop counters. Okay, normally always keep in mind that while using this two-dimensional array concept, while doing matrix manipulation programs, we have to use that nested for loop. Okay, because see here, whenever we are on the first row, we will accept these 3 elements, means, and the same thing we will repeat number of times. That's why for outer loop will be for rows and inner loop is for accepting individual element from that row. Okay, whenever value of I is 0, we are at this place. Here it will move from 0, 1, 2. Then this element will be having I value, means first dimension 1, and second dimension will be here 0, then 1, then 2. In this way, row dimension will be fixed. Okay, for all these 3 elements. Column will get changed. Here row dimension again same for all these 3 elements, column will get changed. And for that column we will use inner loop, for that row we will use outer loop. In this way we have to use nested for loop for handling these type of matrix programs. Again, handling two-dimensional array we have to use nested for. Now see, first I will write like this. We will give message to the user like enter the matrix first, like printf enter the matrix. Simple. Now here see, for accepting we have to accept here individual elements, all elements, 9 elements we have to accept here one by one. First we will accept first row, then second row, then third row. Okay, from first row first we will accept 3 elements, then for second row we will accept 3 elements, and for that rows we will use outer loop, like for I equals to 0, I less than 3, I plus plus, because see always array index starts with 0 and ends with size minus 1. That's why whatever you are using, whatever nested loop, or if you are handling one dimensional array, then you will use single loop. Always keep in mind the loop counter will be from 0, will should start from 0 and up to size minus 1 it should move. Okay, that's why I have placed here 0, and less than 3 means it will move from 0 to 2, because see here the index will be 0, 1, 2 row index, and column index will be 0, 1, 2, 0, 0, 0, 1, 0, 2. In that way, see here the row index will be here 0, 1, 2, and here column index will be here again 0, 1, 2. This element will have row 0, column 0. In this way, again this element will have 0 row, column 1. In this way all the elements will get stored internally again. But internally after this row, these 3 rows elements will get stored, and after that these 3 elements will get stored internally. The two-dimensional array will get stored just like one-dimensional array, contiguous. See, after placing this loop, we have to place inner loop, okay, for moving from this 0, 1, 2. Getting? Now for j equals to 0, j less than 3, again j plus plus, here column dimension and row dimension is same. Okay, for row place outer loop, for columns place inner loop. Now here scanf %d comma ampersand, this one is what name of array is m of 0, 0, 0, 1, 0, 2 means m of ij. That's it. This is how to accept matrix from user. Now we have to display the matrix in this way only. We cannot place this symbol, but we can display the matrix row wise properly. How? See, the matrix is first, see here this scanf statement will execute 9 number of times. Whenever I is 0, then it will execution of the scanf statement will be 3 number of times. Whenever I will be 1, again this whole loop will get executed from 0 to 2. That means again this scanf statement will execute 3 number of times. And whenever I will become 2, again it will get executed 3 number of times. Means total 9 number of times this scanf statement will get executed and all the 9 elements will get accepted. Now how to display? See here I have written print up the matrices. Now we have to display the matrix in this same way. Again put that nested loop, like for I equals to 0, I less than 3, I plus plus. Again same thing for j equals to 0, j less than 3, j plus plus. Now here we have to display, that's why I am using printf. Printf %d, give some space. For that we can put /2 or we can give here some space also. Okay, because every individual element whatever we are displaying, after that we have to put some space. That's why in printf I have written like this, printf then give some space and then display the element. Like the matrix name is m, here we have to use m again, m of I j. Getting? Now in this way we will display the first, this inner loop will display first row, then again it will change the value of I and will display the second row. After displaying all the 3 elements from first row, the cursor should get moved to the new line. That's why after displaying this, for new iteration, for next iteration of I, we have to move to the cursor to the new line. That's why I am writing here like printf /n. It is compulsory while displaying the matrix, that then only the matrix will get displayed properly. Okay, otherwise it will display all the elements of matrix in single row if we have not placed this /n, or even we can also not place here /n. Otherwise in that case also all the elements will get displayed one by one, means every element will get displayed in new line, like 5 then 6 then 7 in that way. That's why always keep in mind, after displaying one row, the one row will get displayed by this one inner loop. Iteration of the whole loop will get executed, then it will display one line. And for second line, before moving to the next iteration of outer loop, because next iteration means we are going here, before that we have to go to the new line. The display cursor should get moved to the new line. That's why we have written here printf /n. In that way matrix will get displayed, and now we have to stop. That's why main will get closed here. We have to close the main here. Getting? This is the program how to accept matrix and how to display matrix. If you don't know how many number of rows and number of columns are here, means what is the exact dimension of that matrix, if you don't know, then what should be done? Here you can declare some maximum size, let 5 by 5. And you can accept number of rows and number of columns in from user here only, like printf enter rows, means how many rows are there. In this way then scanf %d comma %r, let we have declared one variable like r for rows and c for columns. In the same way we have to accept columns, and that row we have to place here r and we have to place here c, and same thing we have to do here like r and c. In this way this program now is capable of accepting matrix of any dimension, but the dimension should be less than 5 by 5, means less than or equal to 5 by 5. Okay, means 2 by 3 okay, 3 by 2 okay, 5 by 4 okay, 4 by 5 okay, everything. But 5 by 6 this is not again capable, because we have declared here maximum size 5 by 5. Okay, now this program is capable of accepting matrix of any dimension. Getting? Now I am going to explain here program to accept a matrix and transpose it. Not only, we are not here only displaying transpose of that matrix, not only display, we are transposing the matrix itself, means internally the matrix should get transposed. Now how the concept is actually, first see, let this one is a matrix like 5 6 7 1 2 1 and 9 3 2, then transpose of this matrix will be like this, like the rows will get converted into columns and columns will get converted to rows. Okay, now the transposed matrix will be like this, the first row will be the first column of that matrix, like 5 6 7, then 1 2 1 and then 9 3 2. This is a transposed matrix of this one. Actually we have to transpose the matrix itself, whatever we have accepted. Means this should gets converted in this way, and for that I am going to explain program how to do this transpose. See, we have I have written here the, how to accept matrix and how to display the matrix. We have already seen logic for that. Again I am going to explain. See, 3 by 3 matrix we have declared here, I and j for outer loop and inner loop. Here we have given, I have written like printf enter the matrix. This message will get displayed onto the output screen, and we have to accept the matrix. That's why I have put here two loops, like for I equals to 0, I less than 3, I plus plus. Then same thing for columns, like j equals to 0, j less than 3, j plus plus. Here I am considering 3 by 3 matrix, and we have accepted here individual element of that matrix, that is nothing but m of I j 0 0 0 1 0 2. That's why using scanf I have accepted whole matrix, and same way we can display the matrix. Now how to transpose the matrix? Before displaying that matrix I am going to transpose that matrix. Okay, to accept the matrix, this is the program, I mean this is the loop, and now here I am going to transpose the matrix. See what to be done here. So consider we have accepted the matrix, and now we will do, here we have to write code for accepting the matrix. Now after that we will do the transpose. Okay, while transpose of a matrix, how to do that? See, in this matrix and in this matrix you can see that here first element will be as it is, this one will be as it is 2 2, and this one will be as it is. And now lower triangular matrix is shifted here, and this one is shifted here. Now we can do like this. See, here I and j is same, here also I and j is same, here also I and j is same. See, if I here at this place, see value of I is here 1 and value of j is 0, means I is greater than j here. Here again I greater than j, and here 2 and 1 I greater than j. If I is greater than j, then we can swap these elements, means 1 will be at this place and 6 will be at this place. That logic we can apply here. See how, here I will write like this, if I is less than j. Okay, if I is less than j, then what should be done here? M of ij should becomes m of ji, means in that we can use swapping technique. Like we will declare one more variable here like int temp, then we can write here like temp equals to m of ij, then m of ij equals to m of ji, and then m of ji equals to temp. This is only the logic to transpose the matrix. See here what I have done, I have considered this is the structure actually. Like here index of row index of this element is 0, for these elements it will be 1, for these elements this will be 2, and column index is like this 0 1 2. See, these elements, whenever I and j both are same, the elements will be as it is. Okay, now we have to change these elements, we have to shift over here like this. 1 9 and 3 is here in transposed matrix, and 6 7 and 1 are here. Means see, m of ij means this element is m of 1 0, should be here at this place m of 0 1. Okay, this place is m of 0 1, means we have to swap, we have to exchange the position of element. That logic I have applied here. Using temp variable we can swap two variables. In the same way I have exchanged the position of these elements, and then after displaying the matrix we will get transposed matrix here. Now see how to initialize one dimensional array. See, let array is like this, let int x of 5. Then how to initialize it? Using curly brace we can initialize one dimensional array like 5 comma 1, then comma 2, then let 7, then comma let 9. These are the 5 elements. In this way we can initialize one dimensional array. Here this 5 is optional because if we are initializing array at the time of declaration, then that's whatever size we are mentioning, that is optional part. In the same way we can also initialize two dimensional array. How to do that? See, while declaring two-dimensional array, we have to specify row size and column size both. Then we will write like this: integer let x, row size is let it is 3 and column size is let it is 2. Means 3 number of rows and 2 number of columns are there in this array. Means group of 3 arrays, each is having 2 elements in it. Okay, that is a two-dimensional array. Now see how to initialize it. Now here there are total number of elements are 3 into 2, that is 6 elements should be there. Now first array we will write like this. Again I am putting here curly brace. Initially I have put here curly brace. Then again one more curly brace I am putting here. Now here I am giving one element, like it is having 2 elements in it. First array we will write here like 3, 7. Okay, then comma, give one comma, then again put here second array. Here I am placing like let 10 and 9. Then put comma, and then third array we can place like this, like 11, 7. And again place that curly brace and give semicolon. This is how we can initialize two-dimensional array. Now the first element of that array will be 3, second will be 7. This is 0, 0, 0, 1, 1, 0, 1, 1, 2, 0, 2, 1. In that way. Okay, in this way we can initialize two-dimensional array. Now how the internal memory representation will be? See, here 3 by 2 means 6 elements will be there. So considering one integer is taking 2 bytes. See, the higher compilers or higher system configuration will take 4 bytes for one integer. Here I am considering 16-bit system, that's why I am considering 2 bytes for one integer. Total 6 elements should be stored here, and for that 12 bytes will get allocated in a memory, and allocation will be contiguous. Okay, allocation will be contiguous in this way. First 2 bytes for first element, second next 2 bytes for second element, and this whole will be the first row. Getting? Now then next 2 elements will represent the next row. Next 2 elements will represent the next row in this way. Getting? Now this is the element, that is this is the first element, that is nothing but x of 0, 0. Then x of 0, 1. Getting? Now this element is nothing but x of 1, 0. Then x of 1, 1. Getting? Now next one x of 2, 0. And x of 2, 2. Getting? This 0, 0 and 0, 1, these are the elements of first individual array. Then 1, 0, 1, 1, second array and third array. And this is the group of 3 arrays, that's why it is a two-dimensional array of size 3, 2. Getting? Now here we have given first array elements like 3, 7, those will get stored here. Then next 10, 9 will get stored here, and 11, 7 will get stored here. Getting? Now the addresses are like this. If the address of first array starting address is 100, then this one is of course 102, then 104, 106, 108, 1110. The addresses are again contiguous like this. Okay, if we know the base address, then we can get all the addresses, we can fetch all the addresses, all the elements, all the individual elements of that array. Now see, one more point is there. If we are initializing array at the time of declaration, this is nothing but declaration of array, and setting initial values, that is nothing but initialization of that array. In case of the one-dimensional array, we have seen that if we are initializing array at the time of declaration, then size is not compulsory. But here in case of two-dimensional array, keep in mind, we cannot like this, that x and in this way, we cannot specify like this. We column size, we have to specify compulsory, it is compulsory. Okay, means here each individual array will have 2 elements in it. That we have to compulsory mention. The row size is optional part, but column size we have to mention compulsory. That point should be kept in mind. Now one more point is there, the same initialization we can do in this way also. See, in this way, like we can write int x is equal to 3, 7, 10, 9, 11, 7. That is again okay, that is again fine, no problem will be there. This is also perfect, but here it is not readable. Okay, this is properly understood. Okay, in this way, suppose we are initializing array, then this is the better way, readability will get improved here. We can maintain program easily here. By looking on these elements, we cannot say that the first row will have which elements, second row will have which elements. In that way we cannot say here anything about this array. And here again we have to compulsory specify these two, because now the compiler can understand that each individual array will have two elements. That's why it will group together two elements, and now whatever row size it will calculate, that is 3 here, and that will get assigned here. Row size will be considered here, 3 size automatically. Getting? Now see, in this way also we can initialize the array, and this is the best way actually. In this way also we can initialize, no problem will be there. Internal structure will remains same in this case. Now next point, let we know the address of first element. See, address of first element is always in name of array, we have seen. Okay, here name of array is x, and x will hold address 100. Again same thing, suppose we are considering here name of this first array, that will be x of 0, and x of 0 will hold address of base address of that array, that is 100. Again x will hold base address of that whole array, that is 100. Now here second array is nothing but x of 1 and will hold 104 in it. And same way here x of 2 will hold base address of this individual array, that is 108. We can fetch individual elements of array using pointer. Okay, how to do that I am going to explain now. Pointers and arrays. See, we know that array name itself holds its base address. That's why x is a array name and it will hold base address. Suppose you are displaying x, then you will get base address, that is address of first element of that array, that is 100 here. Okay, now that is nothing but address of x of 0, 0, that is nothing but x. Getting? Now if you want to fetch individual row, that you want to get base address of individual array from that two-dimensional array, then that is again possible with the help of x of 0, x of 1 and x of 2. See, if you are displaying x of 0, then you will get address 100, x of 1 you will get address 104. X of 1 is not any individual element. X of 10 will give you the element 10, x of 11 will give you the element 9. But if you are using only one dimension, x of 1, that is nothing but address of that individual array, base address of that individual array. Getting? In this way the pointers are linked with arrays. Here x of 0 will hold 100 and x of 2 will hold, this x of 2 will hold 108 in it. Getting? Now how to access these elements with the help of pointer, that I am going to explain. In case of one dimensional array, we have seen all these concepts, like how to access elements of array with the help of pointer. In that we have already discussed array name holds base address of that array. Now see, I want to fetch this 10 element. Okay, 10 is what? This is x of 1, 0. We will get 10. The same thing we can access in this way also, like x of 1 plus 0 and value at that, means star x of 1 plus 0. How? See, x of 1 means what? It is the base address, it will give you base address, that is 104, plus 0 means of course 104, and star 104 means it will of course will give you value at that address, that is nothing but 10. Getting? This is the formula, that is x star x of 1 plus 0. Now see how to generalize it again. X of 1 means what? X of 1 is nothing but we have seen in one dimensional array, that is x of I is equals to star x plus I. Getting? The same thing we will apply here, like x of 1 plus 0, that is nothing but star x plus 1. in this way, and here plus 0. 1 is what? This is I, and for 0 we can use j. Okay, then how to write this in general? We can write like this: star x plus I and then plus j. This is nothing but how to get individual element of that two-dimensional array with the help of pointer. See, in general we can write like this: x of ij equals to is equals to star in bracket star x plus I plus j. This is a generalized formula to access individual elements of two-dimensional array with the help of pointer. Array name always holds base address. Here if you know base address, here x is the name of that array and that is holding base address. In that, suppose we are adding I value, that is nothing but row number, and getting value at that, and value at that is nothing but address of that individual array, and in that we can add the column number to fetch individual element from that. Means actually column number if we are adding, then we will get address of that individual element from that one-dimensional array, which is a part of two-dimensional array, and then from that we can fetch value from that location. See how we can use this. Again, see, I want to fetch this element, that is 7, that is nothing but x of 0 1. Then whether we are getting or not, we will check here. See, we will write like this: star x plus 0 plus, see here round bracket should be there, plus 1. Now how we will get that element? See here, whatever initialization I have done, that I will rub. See, star x plus 0 is nothing but x of 0 and plus 1. That's why star x of 0 means what? X of 0 is 100 here. 100 plus 1, that is 102, and value at 102 is nothing but 7. In this way we can get the value. Okay, like star x plus 0 is nothing but x of 0. X of 0 means what? Base address of that individual array, that is nothing but 100 here. 100 we will get, plus 1 if we are doing, then plus 1 means 102 we will get here, and value at 102 is nothing but 7. In this way, this is the generalized formula for accessing individual elements of the two-dimensional array with the help of pointer. Getting? Now here we have covered all the basics of two-dimensional arrays, and we have done some programs with the help of these two-dimensional arrays. We can do addition of two matrices with the help of this two-dimensional array concept again. Now what is the logic for that? See, suppose we have accepted two arrays. Let we have declared two arrays like integer a of 3 3. This is first array. Suppose we have to declare second array like again b of 3 3, and we can do addition, and that addition we can store in third array like c of 3 3. Now here what should be done? First accept that first array, whatever logic we have discussed. Okay, to accept the array. For I equals to 0, I less than 3, I plus plus. Again for j equals to 0, j less than 3, j plus plus, and scanf a of ij. In the same way we can accept second array. And for addition, what will be the logic? See here, for adding two matrices, we will use that logic, like we will declare two counters here, I and j. First we will accept first array, then second array we will accept. After accepting both the arrays, we have to write logic for addition of those two matrices. See, let the first matrix is like this, 3 by 3, this is 1 2 3 1 1 1 1 2 1. In this way the first matrix, like A matrix. Then second matrix, consider like B is like this, suppose. Okay, I want to add these two matrices. Then what to be done? See, this matrix, this element is nothing but A of 0 0, then A of 0 1, in this way, then 0 2, and this one is B of 0 0, then 0 1 0 2. In this way all the elements. Then this one is 1 0 1 1 1 2 2 0 2 2 2, B of 1 0 1 1 1 2, B of 2 0 2 1 2 2. In this way all the elements of matrix. Then I want to suppose calculate addition of this A matrix and B matrix. Then we can do that with the help of our normal logic, again this element should be added to this one, and that will be the element at that same place, that is 0 0 in that resultant matrix. Then how to achieve that? See what is the addition here. If we are adding these two, then what will be the output here? See the resultant matrix, we have to add corresponding elements, means here I j will be same. Okay, 1 0 0 and 0 0, 1 plus 1 2, then this 2 plus 1 3, 3 plus 2 5, here 1 plus 2 3, this 1 plus 1 2, this 1 plus 3 4, here 1 plus 3 4, 2 plus 3 5, and 1 plus 2 3. This will be the resultant matrix, and that we will store in C matrix, C two-dimensional array, and that we will display as usual whatever logic we have seen to display the matrix. Now how to do addition? Simple corresponding elements we will add and we will store in that C array. How? See, for first we will put outer loops as just like we have used for accepting the matrix and we are displaying the matrix. Same loop we will use here. I is equals to 0, I less than 3, I plus plus. Then here for j equals to 0, j less than 3, j plus plus, and just here we will do like this: C of ij equals to A of ij plus B of ij. Corresponding elements we have to add, and this is nothing but the logic to add two matrices. This is just a logic, very easy. Okay, here first value of I is 0, j is 0, that time C of 0 0 equals to A of 0 0 plus B of 0 0, that will get stored here inside C of 0 0. In the same way all the elements will get added, corresponding elements will get added and will get stored inside this C. Here one condition is there, that the dimensions of both the matrices should be same, and the resultant matrix will also have the same dimension, that is number of rows and number of columns. And in this way we can do addition of two matrices, and whatever resultant matrix that is in this C array, okay, that we have to display. Again putting these two loops, just printf here C of ij. Getting? There are multiple programs possible using these two-dimensional array concept. I will upload the videos for these two-dimensional array programs in a separate videos. Okay, what is array we have seen? That is, array is a group of same kind of data elements, that is a homogeneous data element stored contiguously in a memory. Array can be used to group together multiple elements of same data type, and two-dimensional array is nothing but array of arrays. Okay, if you want to manipulate matrix, then you can use this array of arrays concept, that is two-dimensional array concept. That's all about two-dimensional array. Thank you.